Hello everyone, welcome to the video series on interesting topics of modern Python programming, and in this particular video we will talk about Python objects and classes. Now you all know that Python is an object-oriented programming, but if you want to gain more understanding about what exactly is meant by object-oriented programming, I will highly recommend you to see my video. You can see a card over here. Okay, so in here I have talked about why object-oriented programming was created. Now let's talk about Python. But before we go ahead, just a quick refresher on what is an object. An object consists of characteristics and behavior. Characteristic means the things using which we identify an object. Behavior means what all that object is capable of. For example, you can identify me by my name or maybe my how I look, and my behavior will be I create YouTube videos or something like that. So everything in this world can be an object, because think about anything. Think about this laptop, mouse or lights, anything. Everything has some characteristics and the behavior. Now let's try to understand how we can use the same concept in Python programming language, because Python is basically a object-oriented programming language. Now to properly understand the same, let's take an example of a postal address. So a postal address consists of name and the address, street or zip code, something like that, right? So we need to represent a postal address as an object first, okay? So I have just told you that everything in this world is an object, which means postal address can also be an object. So let's first talk about the characteristics of postal address. The characteristics will be name or street address, like this, right? Let's hold on to behavior for now. We are only talking about characteristics of an object. Now before I go ahead and write code for Python, let me tell you one of the basic data structure of Python called dictionaries. We can also represent the object characteristics using dictionary. So let's first talk about dictionaries. So here is how you can create dictionary. So I have created a dictionary as a name value pair. Dictionaries are nothing but a hash table in Python programming language. So I have created two dictionaries, name with ABC and DEF, street as central street 1 and 2. Okay, so this actually represents the characteristic of an object, right? Now let's try to represent the same thing using the class syntax. So what is a class? Class is nothing but a blueprint of an object, and it is called an object when it occupies the memory. Okay, so let me create a class called postal address, and I'm not doing anything right now. So the beauty of Python is that you can create member variables at runtime. So let me create an instance of a class postal address as this one. You can create the instance of a class, and you can add a variable called member variable called name and provide ABC and also street, and can say central street 1. Sorry, it's CP1. Okay, similarly I can create another instance of postal address. So can say CP2 and CP2. Okay, so now I have created the object of a class as well as a dictionary. Now before I go further, I'll tell you one thing. We can see the individual members of a class in the form of a dictionary by using, let's say, print cp1 inbuilt dict. Okay, and we can do the same thing for cp2. Okay, so I go ahead and run this code. You can see that name is there, ABC is, because I have not changed it to DEF. Let me change it to central street 2. If I go ahead and run it, you can see the output is similar to what dictionary I have created over here. It's exactly similar. Now do not jump into a conclusion. This doesn't mean that Python object stores individual members as dictionary. This only means that we can get the individual members in the form of a dictionary, because there are other ways to store that also. In fact, the member dictionary will not be available if you are using slots, something which we will talk in some later videos. Okay, now let's come back to this, and you will say that, you know what, both are same. Why should I use class as compared to dictionary? So if you are in a situation where you just need to depict the characteristic of an object, no behavior, then you do not need classes. But you need classes if you need a behavior. For example, let me put a first behavior. For example, change name. So I'll create a function called change name. I'll say new name. In here I'll say self dot name equal to new name. Okay, so if I go ahead and call this function for, let's say, in here I call this function for cp1 dot change name to some garbage, and if I go ahead and run this code, you can see that this garbage is the new name. Okay, this is something you cannot do in dictionary. You have to manually change that particular member name, and you have to do it for each and every dictionary items. In here you are just having a function. You can call this function in a loop or any number of times. The behavior will be similar, but in dictionary you will have to change each and individual member for every dictionary item, which will be quite tedious. Okay, of course, with the simplest example, you still might think that you can do that programmatically. Well, programmatically you can do everything, but when your code grows, this is where this class concept is really helpful. Now, I have shown you two ways of creating the characteristic and a behavior of an object, but both these ways are not correct. Yes, you have heard it right. You should not do it in this way, because you know what? Just imagine what will happen if I change name to names over here, and also in CP2 name to names over here. Okay, I can easily do some spelling mistake, right? So if I go ahead and run this code right now, nothing will happen. But if I call change name on CP2, I'll get a new variable as name added over here, not the existing name that is being changed, because there is nothing available with name. It is names. Okay, so these kind of things, these kind of mistake you can easily do, and that's the reason we have to initialize, or we must initialize all the member variables in the constructor function, so that no matter how many instances you create, all of them will get same member variables. And here is how you create the constructor function of a class. You write a function as def underscore underscore init underscore. This is your constructor function. So if you say self dot name equal to whatever abc, self dot street equal to whatever something right now. Okay, so what will happen, that no matter if I create this instance or this instance, okay, the name of member variables will be name and street. Now we are assigning the name and street outside, right? Let's not do this. Okay, what we can do is that we can take additional parameter called name and street, okay, and assign it to name and street. And in here we can just pass the constructor parameters as abc and central street 1. Let me get rid of this, and in the postal also I'll pass def and central street 2. Okay, and let me get rid of this. Let me comment this for a while, and if I go ahead and print it, you can see that the dictionary representation is printed. And if I change name now, name will be changed. So that's why you should do it in the constructor function of a Python class. Now, one very important thing, what if in the change name function I change it to names? What will happen? What do you think? Let's go ahead and run, and you can see that it hasn't impacted the original values because there was no member variable name as name. It has added a new member variable called names. So this means that you can add member variable in any function of your choice. Even if you are writing 10, 20, 100 function, you can create a new member variable in any function. Please do that only and only if you are sure that there will not be any functions which will be called before that particular function, and it might be using the member variable which is being created. Otherwise it will lead to an error. That's the reason, as far as possible, make sure that you have everything within the init function. It saves you from lots and lots of programming problems. So if you are coming from a object-oriented programming background like C++ or Java, you might be used to of something called overloaded constructor, where you can have a default constructor as well as overloaded constructor. Sadly, something like this is not possible in Python. So what we can do is that we can create default arguments. So what we can do is that we can create, or we can give a default argument to name and default argument to street. So now what will happen that if I create an instance, let's say cp3 of postal address, without passing any argument, this is also fine. And if I do it by passing only one argument, let's say xyz, this is also fine. And if I pass both, this is also fine. Okay, so there is no concept of overloaded constructor. All you have to do is by passing default argument, you can call the constructor the way you want while instantiating the class. Now, one more important difference between C++, Java and Python is that something which you cannot do in C++ or Java unless and until your function is a static function is by calling the this change name function by the class. So what I can do is that, let me comment this. Instead of let me comment this, or maybe get rid of this line. So what we can do is that instead of calling this via instance, we can also call this via class, let's say postal address. But if we do that, we'll have to pass the object instance as part of this. So if I go ahead and run this, you can see that still cp2, in the cp2 names is added, and if I pass cp1 over here, you can see in cp1 names is added. That cp1 itself, you know, everywhere in all Python function you will find a self. Now self is not a keyword. Okay, you can have anything here as you want, your name or anything you like, but it's kind of become a de facto keyword where in almost all Python code you will only find self. So it is a de facto keyword, but this is not a keyword. Okay, so this self is this instance, but if we call this instance like this, the self is passed automatically because the interpreter knows about it. Okay, now let's talk about class variables. This is very important to understand object-oriented in Python. So you know what, when we are collecting a postal address of people in the locality, most likely their zip code will be same. So instead of asking everyone to provide, or every instance to provide a zip code, I can create a zip code like this, self.zip equal to, let's say 12345, which will be true for everyone. Okay, so every instance created will have a zip code of 12345, as you can see over here, right? Now consider this scenario. What will happen if for some reason zip code changes? For any reason, for reorganization of states, counties or district, if the zip code changes, what will happen then? Then you know what you have to do. You have to go ahead and call a function called def change change zip, new zip, and in here you will say self.zip is equal to new zip. And for everything you have to call, like say cp1 dot change zip, let's say new zip code is 54321, and do the same for cp2. Okay, this will work, but this is a bit tedious way of doing it. Here comes the concept of class variables. So there are some characteristics which are there which can change from object to object, but there are some characteristics which will not change. For example, in a human being, heart and brain, that one heart and one brain will be there. It's unlikely for a human being to exist without heart and brain. This will be there. So they are class variables. They will be there. So what we can do is that instead of saying zip code over here, we can create a class variable called zip codes is equal to 1 2 3 4 5 first. Okay, now let's say we do not need this change zip function and this. Okay, now I have a class variable called zip codes. Okay, so if I go ahead and run this code, you can see that the class variable is not coming as part of object dictionary because the class variable is a part of class dictionary. So to print class dictionary, you will have to say print, let's say class dict equal to postal address dot underscore underscore dict, same thing. Okay, so if you go ahead and do that, you can see that in class dict you will have zip code. Okay, so this is a class variable. No matter whatever object you create, this is your class. Okay, and if I go ahead and change it to 54321, you can see that it will change for the class. Okay, you can also change the zip code by let's say if it is 1 2 3 4 5, you can directly change the zip code by saying saying the class name as postal address dot, let's say zip code equal to 54321, and you can see that the same will be reflected over here. Now if there are class variables, there will be class methods. Okay, it works more like a static method, but Python gives you lots of flexibility as compared to C++ or Java. So let me create a class method. So there is a decorator. You need to explicitly tell Python that this is a class method and the decorator is class method. Don't worry, we will talk about decorators a lot in upcoming videos. So now let's write the class method. I'll say def change zip as instance function take self, class methods take class. I'll say new zip and I'll say class dot zip codes equal to new zip. Now the calling will be very interesting over here. Now in here, instead of calling this class member variable directly, I can of course call a class function. Let's say change zip and I say 54321. So if I go ahead and run this code, you can see that zip code is changed to 54321. Now the very interesting thing, unlike C++ and Java, you can call this function, the class method, using instances also. So if I go ahead and do this, you can see that still it is changed, and if I say cp2, still it is changed. Okay, so it doesn't matter whether you are calling class method via a class or via instance. So but you know what, I'll recommend you to call class method using the class name itself, because you know what, if somebody else is looking into your code, it's very difficult to just see this function and understand whether this is an instance method or a class method. Okay, so a small recap. Object consists of characteristics and behavior. Characteristics you can very well define using dictionaries, and in class it's good to define all the characteristics within the constructor init function. There can be only one init function. There can be class variable which is for a class, and there can be instance variables which is different for different instances. There will be class method, okay, and class method can be called by class as well as by instances. So we can also see the dictionary representation of member variables within a class. So that's all about a basic introduction of object and classes in Python programming language. I hope I was able to explain things in the easiest possible way. Thanks a lot. Thanks for watching. Please take a moment to like, comment, share and subscribe. Thank you. Thanks a lot. Good day. Take care. Goodbye.